Welcome to office hours for module 1. Just before we get started, just a reminder that this is being recorded. We'll pop it on YouTube afterwards. And, you know, as always, hey, Felipe, use the chat, even if you've joined before, and just use the chat to say hello, because it's helpful to just for new people to meet everyone. And yeah, just say hello. And I mean, there's only, it's a pretty chill group, so you can just turn your videos on and mics on, so it could be pretty interactive. But if you've got questions you want us to cover in the session today, at least put your hand up or drop them in the and just a reminder, let's all be encouraging of each other and supportive and just aware of different experience levels, and just appreciating that people might be learning at different paces, and there are no stupid questions, because if you've got a question, someone else is probably thinking it as well, so you're doing everyone a favor by asking. And just a reminder that we've got the group live on WildLabs, and it's super active, so jump in there, and there's a lot of side conversations going on already, which is great. And if you need help otherwise, you can always drop us an email at community@wildlabs.net. That comes to me, so yeah. It'll be a friendly face at the other end. That's it for me. I'm going to hand over to Akiba and Jacinta.
Okay.
And I will start sharing. Okay, just bear with me a second.
Ooh.
Hey. Woohoo! Can everyone see? Module 1. We made it through module 1.
Yay!
7 more to go, actually. So this is the first office hours. As Steph said, it's pretty casual, low key, really a place just to ask questions and share knowledge and stuff. So what we will do is just do a really quick recap. In module 1, it was lots of theory and lots of concepts, but as you go through the rest of the modules, you'll start to see how that plays into building the data logger. So you can, and you've got it as reference to go back and look at it if and when you need to. So we started with the process from development straight through to deployment and ongoing dev and maintenance, and talked a little bit about each of the stages that we do here at Freak So proof of concept, prototype, deployment, ongoing dev and maintenance. We also dived into the hardware design stack and broke it up at different layers to help people visualize a bit better which points we're coming in to do the coding and what we're expecting to be already done for us. So we looked at the physical hardware, going through peripherals, which is basically the hardware that attaches to the circuit board, and divided that into input, where data is sent to the CPU, or received as output from the CPU, or both. We looked at the circuit boards, what the central processing unit is. We're using a microcontroller unit, not a microprocessor, so we debugged or demystified some of the terminology. We talked about ports and interfaces, where you plug things into the board, and we talked a lot about input and output pins and digital and analog input and output pins and the way that data is transferred. We also talked about memory, so random access memory, flash memory, and the type of memory that we've got on the wild logger and why we increased it to 128K. And we went into a little bit of power, talked a little bit about sleep mode and active modes, and gave a quick back of the envelope calculation to help you determine the lifespan of a device. And as we go through into coding the full application, that will become a bit clearer as far as sort of the power profile and so on, especially when you're looking at different kinds of sensors and how often they'll be turned on and that kind of thing. And then we went into the software part of the hardware. So we talked about the drivers, and these are usually written by the manufacturer, and they give access to the hardware. They control the hardware. Libraries are basically a friendly interface or API between the hardware and the application. Often they include the drivers, and again, they're usually written by the manufacturer, but they're also written by other programmers. So that's why we need to test the libraries on our configuration of hardware and the application, which is what we're going to be doing in the remaining modules. So that was kind of it that we went through, and then I guess we can open it up to module 1 Q&A questions and yeah, comments and stuff like that.
Did anyone have any questions that they wanted us to cover? Is this Phil? Is this a? It's so this office hours. That was just a quick recap of what we've covered, and we're going to do a quick view of what's to come. This is really just a space for you to ask questions and check in. I mean, feel free to turn your cameras on, guys. Check in and ask questions of the team as we go along. We don't actually think this module will have that many questions, but it's more looking in the future, like, and expecting in no questions so far from Diego. Expecting more questions to be coming up as we get into like module 3, 4, 5, the more in-depth sort of stuff, right?
Yeah, and we'll go through after we've had some time to chat. If anyone has questions, if they don't, if they're working on a project, they've got questions, we can chat about that as well. But before we end off this session, we'll go through module 2 and also show a little demo of the device that we'll be doing, or the coding that we'll be doing in module 3, so you get a bit of an idea of where it's all headed.
So also, I think we didn't really talk about this on module 1, but I think one question that we constantly get asked is like, what is the battery life of our application? Jacinta goes through the actual math, but like the rule of thumb that we use is basically if your design consumes 1 milliamp, it can last for 100 days, which is about 3 months. So if it consumes 10 milliamps, it can last 10 days. 100 milliamps, which is about a Raspberry Pi, is 1 day. And so basically what we try and do, we normally try and go at around 0.01 milliamp ideally, which is like kind of like 0.1 milliamp would be 1,000 days, which is 3 years. Anyways, so that's the rule of thumb. So 1 milliamp, 100 days, or 10 milliamps, 10 days. Using
and the power, just to kind of build on that, the power tends to depend on things like the sensors and how power hungry they are, how often they're on, what other functionality and application processes that you want to do as well. So there's a few factors that play into it.
Yeah, there's a big discussion thread happening in the forums at the moment around power and batteries and all that sort of stuff. Is it something, so it was great to see it covered in the first module. Is it something you're going to go into in future modules as well? Or is that just the okay.
Because we're, later on then we'll get into kind of the optimization of the design. So like, because like in module 2, then we'll start talking about how like we'll start setting up the Arduino IDE in order to start kind of programming, which is actually probably one of the most important parts. Because once that's done, then we can jump into like the coding. So the in module 3 is where like there's just a lot of the implementation. So module 4 is kind of tying all the functional blocks together, and then that becomes the rough data logger application, and then the finished one is module 5, where we go through optimization.
Nice. Robin, you're looking quite keen. Did you want to ask something? Wait, Robin, you need to turn your mic on.
I just don't want to bore the others, but I could wait for the correct session on weatherproofing, but I can't wait. Just because I'm just having these Eartags out in the forest, and they're failing right now because there's water getting inside. Oh. And do you have an idea on how to code stuff like that?
Yes. Actually, in the industry, like if you get it done at a PCB fab, it's called conformal coating, which is basically they coat it with a urethane clear coat. But what you can do is emulate the same thing just by buying like a spray paint clear coat. So if you're like kind of doing any kind of like model design and you're spray painting and stuff, then normally they have a clear coat that you put on top of it. So what you can do is spray that on top of the electronics, and then that'll protect it from rust and moisture getting in. So the other option is here, let me type it. There's the commercial brand called Plastidip, which is kind of like dipping rubber. Like you dip your circuit into the rubber, and then you need to make sure that it works, because if it fails, then it's going to be really hard to get the rubber off to like try and fix it. But otherwise,
Sure.
then it should be pretty well protected. So, and we'll be getting into like all the different methods as well. Like when we get to kind of like the later modules, which is the like hardening of the design. But yeah, so roughly what you're looking for, I'd probably recommend buying just a spray can of clear coat, urethane clear coat.
Hey
Thanks a
Felipe,
lot.
do you want to jump in and if there's any more clarification for your specific hardware and use in the Amazon? Felipe, do you
No.
mind?
Yeah. Can you hear me?
I can. Lovely to hear your voice. How you doing?
Hey, good. Sleepy. It's 7 in the morning, but good. No, I was just typing the same thing because I often lose many instruments, like even camera traps that are supposedly sealed and stuff like that, because I think it's a mix of the humidity and the temperature as well, because I guess all this temperature changing is not so good for the seals as well. So I was just wondering what else can we do? And I know like this stuff like plastic deep must be great, but sometimes it's hard to get those materials when you're like in Brazil or in Africa or somewhere like that. So any other DIY home solutions or tricks that you can share with us would also be welcome.
I mean, I think for like an enclosed device, like even for the wild logger, what's going to happen is when you deploy it, like depending on like the location that's positioned, it's possible, like, because wild logger should have a gasket which seals it from external moisture, but if you have kind of internal moisture, it's possible that it'll condense, and then there's still possible corrosion or like moisture that'll get on the board. And so in that case, then what I said is a spray urethane. And so that's a common item that you can find at hardware stores, normally in like the spray paint aisle. So, and we'll be showing videos on like kind of demonstrations of how to do it. And then normally it's like 2 to 3 coats. Let's see, I think, yeah, the other possibility, like if it's small circuit boards like the size that Robin had, then it would be heat shrink tubing with hot glue inside. So if you put the hot glue inside, and as you heat shrink it, then the glue will also kind of fill in the cracks, and you just kind of squeeze it. So then it'll just be like it'll just be kind of sealed, completely sealed.
Joseph is asking, what do you think about vent valves?
Vent valve? Like, what's the vent valve? Oh, vent valves. Okay. I was like, vent valves? No. I think like I haven't used vent valves before. I'm not sure if it'll help much with condensation, because I think that like that's really, I think, determined by the environment. Like and I think that generally, like, it's really interesting. So the wildlife community shares kind of exactly the same problems that you have working in environmental monitoring or international development, which is that you're like working in these harsh environments, and you also like very resource constrained, like no infrastructure. And generally the fight that we're fighting against is moisture, like water, humidity, things like that. So that's like the big killers in the field are going to be moisture, any moving parts, any mechanical part is going to fail. It's just a question of when. And if you have cables that stick out, then like animals really like that for some reason. It's like people with a big button and they just want to push it. Like animals see a cable, is like, oh, I think I'm just going to chew through that. So.
And one of the things when we're looking at the deployment conditions, especially when we're looking at the mounting and the enclosures, is trying to waterproof it as much as possible, taking into account some of the environmental. And then taking maybe not so much with the spray cans, we'll try and source it there. But if you're going out into the field, taking some with you so that you've got it on hand if you need to, and or you've pre-coded it before.
You guys are going to talk through like a field kit for like what you should be having in your little kit to go out into the field to test and fix things, right?
Yep.
Yeah, yeah, that's really important.
We'll go over, like, I'm not sure, like, because it's also kind of dependent on the application, but there are general tools that you'll want. And so like you'll want like kind of like especially stuff for emergency repairs. And then aside from that, then you'd want like kind of specialty tools too. So but like Jacinta was saying, like even on like the WildLogger, like on the WildLogger kit, actually it's kind of the demonstration for a lot of the concepts we'll be talking about. Because like even on if you look at the screws, like the original screws that came with the enclosure, we had to take those out because they were uncoated steel, and so they would rust really quickly. And so we actually changed them out for stainless steel screws. And so even like that kind of thing is really important to look at.
Okay,
The other thing that's really helpful is when we're doing the different kinds of testing. So we do the lab testing, we do the sandbox testing, and we do the kind of field before getting out into the deployment. Depending on where you're able to do that, you might find that there's similar kinds of conditions as far as temperature and humidity. So when we were in the Philippines, we were testing in the field before the real deployment. And we noticed that one of the sensor readings on the water levels was just going crazy. Like, what is going on? And we're testing and we're trying to debug. And then we went out and actually had a look, and the sensor was submerged in water. So that said to us that one of the enclosure, there was a leak somewhere. So part of the testing for the each of those test environments isn't just for the board, it's also for the enclosures that you'll be using.
And
hey, Robin. Oh, sorry, Jacinta. Sorry, Akiva.
Oh no, it's fine. Please. There was just a funny story associated with that. So anyways.
Oh, okay, let's come back to that. Robin, do you want to go? Did that answer your question? Oh, I've muted you because you're being noisy. Sorry.
Just concerning the testing of the sensors, do you think, or did you think about connecting like a little screen on the device itself? I was like playing around with. Can you see that?
Oh, okay.
Like one of the Wii terminals,
uh-huh,
where you can like plug in your group sensors and it's directly showing your Arduino code and the result.
So one of the interfaces on the board is the I2C, which you can plug an LCD into as well. And the Grove, on the WildLogger, there's no Grove connectors on the baseboard, but then there's shields that you can add onto it.
Like
yeah, Grove shields.
And what? So Grove is like kind of a hardware standard, but actually like, well, I think because we're gonna have like kind of booster packs of accessories that you can actually kind of use. So like the LCDs, because like since you have the board and then like the component, like then it's just easier to just get like the components, like if you're interested in those. And so like we'll have LCDs, other sensors, and then I think we're like later on we'll be doing kind of like bonus videos on like say interfacing. Like there's some really interesting things that would be kind of fun to play with on the WildLogger board. Like so one is having an LCD and being able to read the data directly off the WildLogger board. Some other interesting things that we're looking at is like kind of there's serial camera modules that can be interfaced, and so like combined with the motion sensor, you can create like kind of a like not a super high resolution camera trap, but something where you can start playing with the camera trap and adding on different sensors like like range, things like that. So like yeah, I think we're definitely looking at like just having other sensors, but it was really important for this course that everybody kind of had a baseline of the same thing. And then after that, then people will start saying, well, actually, I've done the temperature and humidity, but I want to try this. And then we can start like kind of, like, and then we can start like taking requests or things like that.
And that's also why we started with things like the pins. How to use the pins? Is it analog or digital? What sort of power do you need to be aware of for each of the sensors and so on? Because when you start playing around with it, you're able to kind of get a sense of how much power the device would use and how it would work.
Is that a sanitary pad on top of the batteries in the chat room? It's like
I'm telling you, man, I'm in the tropics. I have to get around with wherever I can find. But to be honest, I think it's more superstition. And it's the only thing that fits because it's quite small, so it goes on the top of the batteries. Sometimes we use it, but just for fun, I guess.
Everybody has their tricks, so it'll be really interesting to hear.
Hey, Robin, what are you actually building?
You mean with the wet logger?
No. I meant what the question. The what's getting damp.
Oh, this is a LoRaWAN GPS tracker as an Eartag.
Okay.
And so we want to track, or we already track wild boar and want to track roe deer and other species with it.
Oh, awesome.
But right now it's not stable enough.
Okay.
So I have to have like a more stable. It's a hard fight between weight and stability. Always.
What do you mean by stability?
You know, when a wild boar starts chewing on an Eartag that is quite delicate and lightweight, then it's destroyed within a minute. When it's too heavy on the ear, and then it's not good for the animal, and it's like start biting on it. The heavier it is, stuff like that.
Okay.
Ooh, but how do you track them? Do you have some sort of antennas posed in the field, or they transmit the location? I missed that part.
Sorry, could you repeat that?
How do you actually track them? Do you transmit the location, or do you have sort of antennas and stuff in the field to track them? I missed when you explain it.
No, we transmit the location. So it's measuring the GPS data. No, via LoRaWAN. So we have like a system of antennas around the forest.
Yeah.
And then it's transmitting to one of the gateways and then to the internet.
And just for curiosity, what's the range of the antenna to the device? How far can you track?
It depends. Like in the open fields, it's sometimes 16 kilometers, sometimes even more. And in the forest, sometimes it's less than a kilometer. So it depends.
Okay, call me again when it's 60 kilometers in the forest.
I was going to say, what sort of environment are you actually deploying in? Because it may not be so tropical or so more temperate, or.
No, it's just in front of Vienna here. It's a damp forest along the river Danube, and so it's quite wet, quite dense, so quite tough. But on the other hand, I also played around with like a little LoRaWAN gateway that can be put on a drone. So you can fly the gateway over the forest to get a better connection, not for like fixed deployment, but to find a lost animal,
Robin, have you chatted to Rob Appleby about this?
Not about this.
Yeah, he's talking about Eartag. He and Al are talking about Eartag stuff as well. Might be a conversation to pick up. Yeah, interesting.
But with the WILDLABS sensor, I'm really open. there's so much stuff going on, but I really want to discover what I can do and just be open to find out what I can do with it. Probably include it in one of the traps somehow to see whether there's activity along the traps, or maybe with animal borers or something like that.
Ooh, let us know, because we have a bunch of boar living up at like one of our one of our places out here. It's a bit kind of in the forest, and the boar just dig up the whole area in order to find roots. So it'd be really interesting to like learn more about them, because now they have little boar families, and then they've stopped being scared of humans. So whenever they see me, like they don't even like run away. They just kind of go back to their digging. So I'm like, hey, at least show me the respect of running away or something. And it's like, go away, go away.
Same here in Vienna. Actually, they are coming into the city, and we really have to, or in the edges of the city, in suburbs, and we really have to chain our trash bins to the walls. Otherwise, they will just knock them over, and it's a big mess.
Nice, Felipe. Okay, let's question about shipping and stuff. What's the latest from you guys if people are waiting for their wild loggers?
Currently, to the UK, we're seeing approximately like the fastest we've seen is 14 days, and so far I think on average it looks like around 16 days. And also I think it's approximately the same for the US. And the problem is because there's a lot less air traffic and a lot more people purchasing stuff online. So the queues in order to get like to cross the oceans, to cross the countries, are getting really big. So yeah, and like in some cases, then we have to find workarounds. So like I think we were talking about at the beginning is in Australia, there's no direct flights to Australia, at least from Japan, because they've shut down the inbound traffic as well as the outbound. So we use couriers that have their own air fleets, and then we ship them to Jacinta, who is in Australia, and then she ships them out locally from there.
Cool.
So,
okay. But there's still time. Like the whole point of this is you can do it at your own pace.
Yeah.
And
I think the other thing is too, if for example we're up to module 5 and your device comes, you can code along, and then if you've got questions about module 4 or 3 in the module 5 live office hours, bring it along. It's not so strict.
Yeah, and I think that like so and like like if people like I think we'll probably have some version of the office hours that continue like after this. So like so it might be just like me and Jacinta running some kind of impromptu thing. So I don't think there shouldn't be a rush, because like all the content will live on in YouTube, and then you can just kind of work at your own pace. So.
God, we'll be quite sorry. Just thinking of the idea of like just keeping this on. It could be quite fun to have just bring your project along and like show it. Like Robin, I'm expecting a fortnightly update on your project. Just like FYI, we're going to have Robin's corner. Watch it progress, or you steadily fall apart. Either or. Yeah. Okay. So
I think that's a really good, interesting thing too, because once we start getting into the meat of the actual coding side of it, what people are doing, even if it's not with the data logger that they're building, but other projects, because all of that can help feed into what might be covered. It can help feed into looking at different kinds of materials for different deployment environments and so on. So we're also really curious to hear what troubles people are finding. So the questions in the meeting chat just now are really, really interesting. So if people have just got general projects that they're working on, or consistently running into the same kind of issue, maybe we can share some ideas or whatever.
Yeah, I think like it's kind of what the after hours thing turns into in with tech tutors, is that they're just like sharing projects and I don't know, getting the collective hive mind of people who are in this space and knowing either on the conservation or the engineering side, trying to troubleshoot together. I think that's part of the fun. So Robin, really appreciate that you brought this along today. Were there any last questions, or do you want to go on to give us a little run through the next bit?
So,
Hello.
oh, hello. Okay. Well,
Hey,
Cool, I
Diego.
think-
were there other questions?
Diego. Yeah, you hear me?
Yeah.
Hi. I wonder what do you mean with use the command line library in the last part of the first part? And do you mean to use the CLI instead of the IDE? So change things using the serial monitor or something else?
Oh,
So we're
go ahead.
Did I jump?
It's a really good question. We're using the serial console within the IDE. And the idea is that through the command line, you're able to build and debug your program much more quickly. So it's not using terminal on, say, Mac or the actual OS. It's within the IDE.
So, well, also the command line will actually be running on the Arduino controller, the microcontroller, and so that's what we get into in module 3, which is where the first thing that we do is to download and install a command line library for Arduino that Jacinta and I had put together. And then from that, then what we can do is create commands to test out each block of code that we write. And I think that's, and because this type of thing, it's easy to, you don't want to move too fast. So you want to kind of test everything to make sure that you can isolate all the problems. And then once you're sure everything works, and then we integrate it all together. And so we'll be using the command line and showing how to do that.
Good, great.
So actually, because we're going to have a bit of a video to kind of show the wild logger working, and also like a demo video to show what to expect, at least through module 3.
Good, love it. Thanks.
No problem. I think, is Steph frozen or?
I think she might be on here, but what I might do, just unless there's any more questions for module 1, what I can do is go through and share what we'll be doing in module 2. So I will jump ahead and do that. So can everyone see again? Yeah. So in module 2, we're going to be setting up the Arduino IDE if you haven't done so already, and also interfacing it with the WildLogger board. So we'll be installing it, we'll be downloading the board description files and going through what these are and the drivers that we need. And we'll also be going through the Arduino program or sketch structure and the subset of C++ that we'll be using. We'll go through the WildLogger boards and pins and interfaces in a bit more detail, and go through serial communication and why we're using the USB serial dongle. And this is useful because it means that when we're looking at interfacing other kinds of communications protocols or sensors, we're kind of understanding what sort of interface we're using. And then we'll do a bit of a sanity check just to make sure the hardware works. It sounds kind of a little bit sort of tedious, but it's actually so important, because if you're able to interface with the hardware and be confident that you're doing that, then you're able to continue to build up the application. And when you hit something that goes wrong, you know that it's not because you've got a dodgy USB cable or something like that. So we'll be writing our first programs and talking about the power of the blinking and LED, as well as writing Hello World, which is a pretty standard programmer's first program for when you're learning programming. And we'll be using the serial console and sending text from the board to the PC. So that's so that's module 2.
I just wanted to add also, like, if you haven't received your boards yet, don't worry about like the parts in here that require the hardware. They're basically just kind of sanity checks. As if you can get the hardware for module 3 starts, because that's where that'll be when kind of the real, I guess, a lot of the programming is where it starts getting a bit more programming heavy.
Yeah. The other thing that we wanted to mention for those who find the time zone a little troubling, or a little waking up early in the middle of the night and or late in the middle of the night, Carly and Ellie are arranging some watch parties at 5 p.m. ET time or 2 p.m. PT time. There's information up on the forum with some dates, and so you can register for the Eventbrite to get the details and the link for that. And we're planning to have 1 or 2 of the kind of office hours, or a few of the office hours in that time zone as well, just because people are from all over the world. So we want to make sure that we can kind of chat with everyone. So yeah, if that's better suited to your time zone, check out the watch parties at 5 p.m. ET time, and you'll find some info on the thread. So I will pause back and then head back to Akibera and Steph, and yeah.
Sure. I guess so I've put together a little, so we've gotten some requests to actually see how the wild logger will work. And so like so we put together a little pre-recorded demo just to show things. So I think it's about 3 minutes long, so I guess I will take over.
And this is what we'll be doing in module 3.
Yeah. So sorry, it is jumping ahead, but I think a couple people were requesting like kind of how it works, or possibly if it works. So this is just to show.
I hope so. what we're actually building, right?
So here, whoops, hold on. Actually, let me go. I forgot to click on the button, the system audio, and then here you go. So, okay, can you guys see that?
Yeah.
Okay.
Hi everyone, Akiba here. You may be wondering why I did a pre-recorded video, whereas I could just as easily talk about this in real time during office hours. There are 2 reasons. 1, we've gotten some requests to see demonstrations of the wild logger in action. Since I've messed up more than my fair share of live demos, I decided to pre-record it so I won't panic if I do something wrong. 2, it's so much easier to give material this way because I can just read what I'm supposed to say. I love that. Anywho, Jacinta already went through what to look forward to in Module 2, which is going to lead us into Module 3. Module 3 is where the meat of the data logger application will be implemented. We're going to go through it slowly and test piece by piece each of the main functional blocks in the data logger. We'll be using a command line that will actually be running on the Arduino microcontroller on the wild logger board. So first thing to do is to plug in the batteries and the USB and just get things set up. And next we open up the serial monitor in the Arduino IDE. Don't worry if you don't know what that is. We're going to go through that in Module 2. Here you can see the command line. The first thing we'll be doing in Module 3 is to install the library for it and then learn how to implement our own commands. Next, I'm reading the temperature and humidity from the sensor. The units for the temperature are in degrees Celsius, and the units for the humidity are in % relative humidity. We'll also be learning how to install the library for this and implementing the read temperature and read humidity commands. This is the current battery voltage. It's an important piece of information that we can use to track our battery performance over time as we log our data. We'll be learning how to use the analog to digital converter on the Arduino and then implement the calculations to convert that to our actual battery voltage. Here I'm setting the date, the time, and then reading back the time, date, and date time. We'll also be installing the library for the real-time clock and learning how to implement this for both our data timestamp and as an alarm clock to wake the device up and take measurements. And finally, I'm listing the files in the directory on our micro SD card. writing a new data point to the file, and then reading back the complete log file. The file format is CSV, or comma-separated values, and I'm including the date, the time, the temperature, humidity, and the battery voltage. If we track this over time, then we'll be able to see how quickly our battery depletes, as well as how the temperature and humidity fluctuate over time. We'll be installing the SD card library and file system and learn how to implement the commands we need to create new files, as well as write, read, and append to files. That'll take us through Module 3. Module 4 is where the fun begins. We'll be learning slightly more advanced topics like how interrupts work and how we'll be using them as a strategy to save power and increase battery life. And then we'll be doing what we call top-level integration, which means we'll be tying all the pieces up into a functional application. At this point, you should have a working data logger, but not an optimal one, and we'll discuss that more in Module 5.
So I will stop sharing now. And so we put together that video for just as a demo.
My first feedback is that your video voice is wonderful.
Oh, thanks. Yeah, I always feel like my voice sounds strange. So when I hear it, I'm like, oh, is that what I sound like?
No, it was wonderful. That's awesome. I found that helpful to see what's